Okay, let's do another application. So let's say that I am deciding between two cell phone plans, and I've decided to upgrade to a smartphone, going away from the cheesy little brick that I have right now. And let's say my company, let's say I'm going with whatever, AT&T is offering me two data plan deals. So it tells me that one, I can pay, let's say $10, no, what's more reasonable, $20 for 2 gigabytes of data plus 10, let's say, I don't know, $15 for every additional gigabyte of data that I download or transmit. The other plan is I can pay, let's say, $30 for 2 gigabytes of data plus $10 for every additional gigabyte of data I use. Let's turn these into linear equations. These are not going to be linear equations in standard form. In fact, the best thing to do here is to turn them into linear equations in point-slope form. Why? Well, we're essentially given a slope right here. $15 is a rate. Every gigabyte of data I use over 2 gigabytes costs me $15. And here is a rate 2. So in general, let's let y be the amount of money I spend, and x will be the number of gigabytes I use beyond 2 gigabytes. Okay. Then what does Plan 1 say? Plan 1 says the amount of money that I spend is I start with an initial $20, and then I have to pay $15 for every extra gigabyte. We're just writing this in the opposite direction. Y is equal to 15x plus 20. For the second plan, I have that the amount of money I have to spend is $30, which is the base amount of money I'm spending, plus $10 for every extra gigabyte beyond 2 that I use. So that's going to be 10x plus 30. Okay, which is going to be a better plan? Well, let's see when the two plans actually cost the same. Clearly, Plan 1 is good if I'm only going to be using 2 gigabytes. And clearly, Plan 2 is going to be good if I'm using, tons of gigabytes. But at some point, they're going to be equal to each other. How can I do this? When do the plans cost the same? When they give the same y value, because y is equal to the price. So I can set the right-hand sides of the equations equal. And I can't spell today. So I've got 15x plus 20 is equal to 10x plus 30. And now let's just solve for x. If I've got 15x plus 20 equals 10x plus 30, I'll subtract 15x from both sides, and what I end up with is 20. Why don't I subtract 10x from both sides? That makes more sense. And I end up with 5x plus 20 is equal to 30. Then I'll subtract 20 from both sides, and I end up with 5x is equal to 10. I divide both sides by 5, and I end up with that x is equal to 2. Fantastic. I really should have maybe put some space between these computations. Okay. I subtracted 10x from each side, subtracted 20 from each side, and I divided both sides by 5, and I got that x is 2. So when I use 2 additional gigabytes of data, the two plans cost the same. How much? Well, I can use either equation. Let's use the first equation. Y is equal to $15 times 2 gigabytes plus the $20 that I initially spent, which is 30 plus 20, which is 50. Great, I'm spending $50. If I use the second equation, it would be $10 times the 2 extra gigabytes plus $30, which is 20 plus 30, which is 50. It doesn't matter which one I use, I get the same answer. So I am spending $50 if I use 4 gigabytes total. If I use less, the first plan makes more sense. If I use more, the second plan makes more sense. Okay, let's go and graph these lines. And in order to do so, I'm going to have to sort of relabel things. So let's say that this is 25 and that this is 50 on the y-axis, and let's say that this is 1, 2, 3, 4, something like that. So our first line is y is equal to 15x plus 20. That means that our y-intercept is 20, and if x goes up by 1, then y goes up by 5, 10, 15. If x goes up by 1, y goes up by 5, 10, 15. Great. So this is my first line. And my second line is going to be, well, I gotta stop now. My second line is going to be y is equal to 10x plus 30. What does that look like? Here's 30, and if I go up by 1, y goes up by 10. If I go up by 1, y goes up by 10. Hey, look. These two lines hit at this point. This line continues kind of like this, whereas this line here continues kind of like this. Okay. So this point of intersection right here is actually the point 2, 50. So what we actually did by setting the equations equals, we found the point of intersection between these two lines. We can also see that here, this is plan 1, and up here is plan 2. Plan 1 is better than plan 2 when I use between 0 and 2 additional gigabytes, whereas plan 2 is better than plan 1 when I use more than 2 additional gigabytes. Okay, that's what we said before. So great, that is another application.